Here's example 7 with trig identities. If you want to copy this packet we're using for these videos, if you want to follow along with that, check the video description here. There's a link in there. You can click that link, open up this packet, print it out if you'd like. So, whoops. So example 7, cosecant of theta plus cotangent of theta, that quantity times the quantity cosecant of theta minus cotangent of theta equals 1. Okay. So back to our general process from an earlier video. So again, always start on one side, try to make it look like the other side, and usually start on the more complicated side. So I think we can all agree that the left side is a little more complicated than the right. So let's try and make the left, we're going to start with the left side and try and make it look like the right side. In other words, just show that the left side equals 1. Okay. So, okay, what are we going to do here? So start with the left side, so cosecant of theta plus cotangent of theta times cosecant of theta minus cotangent of theta equals what? Okay, so what's something that hopefully jumps out at us that we might want to just do right away is just to multiply this out, right? FOIL it. So remember foiling, so in general, for this type of thing here, if you have a plus b times a minus b, okay, that's going to be a squared minus b squared, right? So when you FOIL, so this is the same kind of thing we have here. Okay, we have this plus that times this minus that, right? So cosecant of theta, cotangent of theta, here's a plus, here's a minus, so it's the exact same thing. Okay, a plus b, a minus b is a squared minus b squared. So when you FOIL, it's first, which is a squared, outer minus ab, inner plus ab, so they cancel, and then L for last, minus b squared. Okay? So that's exactly what's happening here, but just to be thorough, we'll show all the details here. So cosecant of theta times cosecant of theta, that's cosecant squared of theta. Okay? And then outer is going to be minus cosecant cotangent of theta, minus cosecant of theta cotangent of theta. Okay, so outer, so minus because of this minus sign, and then we're multiplying these two guys together. And then inner, plus cosecant cotangent. Okay, so inner is going to be plus cosecant of theta times cotangent of theta. Okay, so when you multiply two things, it doesn't matter what order you multiply them in. So even though cotangent comes first, I'm writing it like this. It does not matter at all. And then minus, so L for last, foiling, F-O-I-L. L for last is minus cotangent squared of theta. Okay, so now what happens? So minus cosecant of theta cotangent of theta plus cosecant of theta cotangent of theta, so those cancel. Okay. So again, it's really just literally the exact same thing as what's going on here, but instead of a and b, we have more complicated expressions, cosecant of theta and cotangent of theta, but the exact same rules apply for foiling. Okay, the outer and inner cancel, just like they would for something less complicated like this. Okay? But again, we just want to show all the details. So anyway, what's next? So now this is just cosecant squared of theta minus cotangent squared of theta. Okay, so there's a couple different ways we can approach this. Now let's look at this and say, okay, cosecant squared and cotangent squared, is there anything we know that relates these guys? Yeah, one of the Pythagorean identities, right? So here's a cosecant squared, here's a cotangent squared. So it's not exactly the same. So a couple different ways we can think about it. We can manipulate this like we did when we did example 4, and we used, I think it was, yeah, example 4, and we used this identity for that. We could do it like that, or let's do it a little bit differently. So since we already did it that other way, let's do this one a different way. So if we look at this identity here, cotangent squared plus 1 equals cosecant squared. Okay, so let's take this and substitute this into cosecant squared. Okay. So this Pythagorean identity tells us that cosecant squared of theta exactly equals cotangent squared plus 1. So let's use that fact. Cosecant squared of theta exactly equals cotangent squared of theta plus 1. Okay. And then we still have a minus cotangent squared of theta out here. Okay. So now we simplify that, what happens? Well, cotangent squared of theta, blah, 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 minus cotangent squared of theta. So they cancel, and we're just left with the 1. And is that what we wanted? Yeah, we just wanted the 1, right? So that's that. Okay, so again, what do we do? Let's recap. So first we just foiled. There's really nothing crazy complicated going on there. It's just foiling like we always do. But instead of x's and y's or numbers and a's and b's or whatever, we have trig functions. Okay, but it's still foiling, so it still follows those same foiling rules. First, outer, inner, last, and when you have something like this plus that, this minus that, the outer and inner cancel. and we're left with the first thing squared minus the second thing squared, okay? And then what we did is we said, okay, cosecant squared, the Pythagorean identity tells us that cosecant squared is the same thing as cotangent squared of theta plus 1. So we use that fact here, and then the cotangent squared is canceled, and we just ended up with 1, which is what we wanted. So check mark, we're good. So, all right, that's example 7 with trig identities. Example 8's coming up next.